I appreciate Bill Spohn and Steve Rogers for being our special guests on this episode of apprenticeship training class virtual session. And actually, what made me think about this is there was a post in one of the Facebook groups that was just talking about, practical measurements that AC technicians and installers should focus on taking. And I want to focus on the kind of the commissioning side of things, because I think that's where everybody is in more of agreement. There's a lot of discussion about what's, an appropriate performance check to do if you're changing a capacitor or something simple like that. But I think in terms of commissioning, everybody knows we need to be doing a really good job. So to start with, I already introduced him by name, but Bill is the chief magnate, the king of TruTech Tools, I think is the exact term. And then Steve Rogers is the president of the Energy Conservatory, which often as TEC. So you'll see that.
If he can be magnate, can I be Grand Poobah?
Yeah, I know. I didn't give you any fancy title. Grand Poobah would be good. Yeah, that would actually fit very well. Anyway, so today's topic is going to be about performance measurements. I'm going to go ahead and give it away that we're going to be talking a lot about airflow, which is a really important topic anyway. But both Bill and Steve are like airflow guys. Now, obviously, we can expand this and start to talk about the house as a system, or the structure and all that. Today, we're going to focus primarily on the system, the actual equipment, the box, the tests you do within the box. So I want to start with you, Bill, because you sell a lot of tools. So you see what people buy. Where do you think, we'll just ask it this way. What do you think are some things in terms of measurements that techs may be under measuring or misunderstanding, even just based on maybe some of the questions you get, or really what you see people buying most often?
I think there's a misunderstanding of like where to measure, how to measure the tools that they have, and knowing the capabilities of their tools. There's a person who shall go unnamed who tried using a very low resolution manometer with a pitot tube.
Oh, I see where this is going. Okay. All right. I just caught on.
You invited me.
Yeah. Fair enough. Well, yeah. So talk about that a little bit. Let's dig into that quickly, and then we'll kind of back out. But
sure.
A lot of people, we'll just go straight into the manometer side of things, because this is something that you're both very passionate about for many of the same reasons and a few different ones. A lot of techs will take a static pressure measurement, and they will say, I'm taking an airflow measurement. Right. So you say, did you check airflow? And they're very proud, and they'll say, yeah, I checked static pressure. So address that specifically. I'll turn this over to Steve. Why is that not a correct way of thinking about that?
Yeah.
Well, it's often the best you can do if you don't have the tools. But the problem with it is that you're comparing the static pressure to whatever the factory determined it was in a brand new piece of equipment. So there's all sorts of things with an older piece of equipment that don't match the factory condition. And the blower chart in the manual is, factory new condition. And if you get accumulation of dirt on the squirrel cage, if you get accumulation of dirt on the evaporator coil, or up here in furnace land on the secondary heat exchanger, all those things are going to completely change the relationship between pressure and flow from what it was when it left the factory. And so while that might be a good way to do it on a new system, if you're troubleshooting an older system, you could really get led down the wrong path and think, oh, the static pressure is looking great, I must have plenty of airflow, when in reality, the only reason the static pressure is low is because everything's all clogged up and you don't have any airflow.
And that needs to be broken down a little further, because I've seen people just take the rating, the static pressure rating on the equipment, and say that's the target number.
Oh, wow. Yeah.
And you threw one phrase in there, the blower chart, that is so important to what you were saying, because that sort of leads into the whole profiling deal with, having the airflow table, the airflow chart, the blower performance chart, whatever. That's really what you were referring to. But some people make that critical error and just look at the equipment static pressure rating, take a static pressure test, and say, I'm fine.
Yeah. You have to have the blower chart for that model from the manufacturer, or you really don't know anything.
Right. And you have to have the original equipment blower, the motor.
Oh,
And,
yeah.
and the squirrel cage or whatever fan is in there, the fan apparatus is in there, because it's profiled with specific equipment. And if you change that equipment, then it's no longer valid.
Yep.
Yeah. And so just in summary, so now that we kind of drilled down, let's back up again. If we're talking about system performance, I've heard it said ABC, airflow before charge. And I think that's a really good way of looking at it, especially on commissioning. We know that there's a point at which we can get a little unrealistic in terms of, like I said off the top, of what a technician's going to do, and they show up and it's a minor repair, it's a clogged drain or whatever, as far as the battery of tests they're going to perform. But if we start with commissioning, that's absolutely true. If you're not getting your airflow set in, then don't focus on the charge until, or really any of the other operational tests, other than just making sure it's not, going to rip itself apart or something because, the fan's hitting the shroud or something like that. Obviously, you want to do some just basic visual and audio visual inspections of it when it gets running. But you really want to make sure that you have that correct airflow before charging. So let's focus on that. And I'm actually going to pull open some of these slides. Now, in defense of RSES, some of these are older and we've actually learned a lot since then, but this is what people will typically say. And even in Measure Quick, it talks about this, 400 CFM per ton being typical, 450 CFM per ton being in cases where you have lower humidity load, and then 350 CFM per ton being cases where you have higher humidity load. Does this stand up? So let's first address this, because I think a lot of techs, the question is, well, how much airflow should I have? Is this the right answer? Do we just take our tonnage and multiply it times these numbers, and that's what we set our airflow to?
Are you asking, is this the right way, or is this better than what most people do?
Well, I think answer both. So,
Okay.
So let's start with, is this better than what most people do? And then let's go into what the right way is.
Yeah, most people, wave their hand in front of a couple of the supply registers and go, oh, airflow's good. That's not a measurement. And, so if you can actually measure airflow, new system, blower chart, or a TruFlow or a flow hood, and actually measure the airflow and verify that what you've got, and then use these numbers, that's way better than what most technicians do, far better. But if you drill a little further and look at what's the right way to do it, you should have, your manual S report, which gives you the sensible and latent split, and you should be setting your airflow to match that sensible and latent split on that piece of equipment. That's the right way to do it, but that's maybe a few more steps beyond where we need to start.
Yeah, exactly.
And speaking of where to start, you've been doing a lot of great tutorials, whatever, on basic physics, Bryan, lately. Mm-hmm. Heat transfer. So air is the heat transfer medium. It's the fluid that is actually transferring the heat off either the heat exchanger or the coiler, or back, vice versa. So you have to know, and that's part of what gets into like the amount of temperature and humidity of the air, the density of the air, that becomes so important in the process. So it's really pretty intricate. But I think not like you have to take that into every situation, but to know that you're working, that the air is part of the equation of how you move energy. HVAC is moving energy.
Yeah. Yeah. And to your point, when we talk in terms of CFM, that's cubic feet per minute. That is a volume flow measurement. And that means that when we're talking about air in terms of a heat moving fluid, and I also like that you said fluid. Since this is an apprenticeship class, this is important to know. Fluid doesn't mean liquid. Right. Both air and liquids, both vapor and liquid state, are considered a fluid. So in the case of this fluid that we're dealing with, its density changes based on a couple key factors. One of the biggest being the temperature, but the other being humidity, and then altitude also plays a big factor in there, and even barometric pressure. So when we say, when we assume that 400 CFM per ton in one location is going to move the same amount of heat as 400 CFM per ton in another location, well, then everything's going to be incorrect. And we know this most glaringly when you go up in the mountains and the air is obviously much less dense, and everybody knows that. Well, you need more of it in order to do the same amount of heat moving. And that's a key thing. And when you start to look at, more advanced calculators, things like MeasureQuick, they're taking into account a lot of these more complicated density calculations. And then also, of course, TrueFlow, same thing. You're taking into account a lot of these more complicated things. So it's just important to know when you're talking about air is actually a little more complicated than we give it credit for. And often that's because we, for whatever reason, want to talk about it in terms of boxes of air, cubic feet per minute, rather than a mass flow rate, which is actually the weight or total mass of the air that's moving through. Sorry, I went a little long-winded there.
I pushed you that direction.
Yeah, you did. It's your fault. I blame you. So Steve, I wonder if you would be willing to talk a little bit about, because we started going down the road of airflow measurement and practical airflow measurements, but talking a little bit about the difference between a system measurement of airflow versus a distribution or point method of airflow. Because I think a lot of people collapse those two concepts. Of, well, I use how do you measure airflow? Well, I use a vane anemometer or I use a flow hood, but that's different than what we're talking about here when we're talking about providing the system the right amount of airflow.
Yeah. So total system airflow, this is, this slide is about the total volume going through the cabinet. So whether it's a furnace or an air handler, how many CFM are going through that cabinet? And that number, you can get there by adding up all the supply registers, but there's a couple problems with that. Number one, accuracy can be an issue. And number two, any leakage that you have between the cabinet and all the supply registers is going to be missed. And so, particularly, we love to make really leaky duct systems in the Midwest because they're all indoors. But you can measure, add up all the supplies and end up with 30% less airflow than what's actually going through the cabinet. So, they typically have two different purposes. Your airflow before charge, that airflow, we're talking about total system airflow, how much is going through the cabinet, versus individual registers. Now you're typically talking about balancing, making sure that you're matching your room loads from your manual J calculation. So balancing versus, set up the airflow and charge on a new system.
And your average AC technician is going to be much more responsible for system airflow than they are going to be the actual distribution system, the registers, what you're putting into each room. Not to say that we're never responsible for that. But I do like to start here because I think a lot of techs, like as we mentioned, even just knowing what generally is considered the appropriate airflow per ton for your market is a nice place to start. And a lot of people will poo-poo that and say, well, that's worthless. So it's not worthless. It's worth something. It's maybe not quite as detailed as it could be, but it is worth something. I want to talk a little bit about this whole concept of static pressure because it is the entry drug. It's where we want people to start if they're not doing anything on the airflow side right now. And here we have a picture of a MagnaHelix, which is the instrument made by Dwyer that's been around for a really long time. It's the first thing I ever used for measuring static pressure. But what are some of the common mistakes that can be made in choosing instrumentation? And then just talk about I guess what some of the challenges are in measuring static pressure. I'm going to turn that over to Bill.
Well, Steve used to work for Dwyer for a little bit.
Oh, really? I didn't know that.
Yeah. On the Smart Hood, actually.
Oh,
yep.
Wow.
In the first MagnaHelix, Steve, was made out of stone. Is that correct? It goes that far back.
Right.
It was brought down with Moses.
No, that was it was the Bronze Age. Yeah.
Yeah. So mechanical gauges like this, mechanical meters like this, they have mechanisms in them. Mechanisms it's kind of like gear trains, needle movement. They can be more subject to the position than, say, a digital one would be subject to position. So laying it on its back, tipping it forward, tipping it sideways can cause the reading to vary a little bit. And then you have to pay close attention that you're reading straight on down the needle, and they make it pretty easy, as a matter of fact, to make good readings. So you're reading straight on down the needle into the indicator on the scale behind it. The electronic ones, I think the unfortunate part about electronic meters is just because they state a measurement range doesn't mean they make the measurement all that well.
Right.
You have to know a little bit about the number that you're after, the quality of measurement that you're after. And if it seems like an amazingly inexpensive device, it's probably amazingly poor results that you're going to get from it.
Right.
Yeah.
Anything to add to that, Steve?
Yeah, I think the one thing that's probably way down in the weeds that most people don't understand, it's right there in the specifications for a lot of manometers. And that is, if it says it's 1% of full scale,
Mm-hmm.
and the full scale is 60 inches of water, which sometimes it is, well, that means that the whole thing is reading plus or minus 0.6 inches of water. So if you're trying to read a half an inch of water static, plus or minus 0.6, I mean, you basically have a random number generator.
Yeah.
And so you need to look carefully at, is it a percent of full scale kind of device and the scale is much higher than where you're trying to read? Or is it a percent of reading device where it has more or less the same percentage all the way down, near to the bottom?
Yeah, that's endemic across all the pressure gauges.
Yeah.
Most of them, or some of them will say MV, the Testo ones.
Yeah.
We tend to change on our side, but that means of measured value.
Yeah.
So it's actually the measurement at that point. But then weird things happen with that because then the error bar kind of blips up when you trip over a certain point, that kind of thing.
Yeah.
And in case you haven't noticed, Bill and Steve are both like super nerds about instrumentation. So that's why we just went off into the weeds about really detailed stuff like this. But it's great because the point is that just because a instrument gives you a number doesn't mean that number is anywhere near correct. And so choosing an instrument appropriately, like for example, with MagnaHelic, this is the exact tool that I would use. And because the range is 0 to 1 inch of water column, it tended to be fairly accurate, but you had to make sure that it was level. And so you had to have it on a stand and it had to be perfectly level otherwise. And then you had to make sure that you zeroed it out. And then you have to make sure, like Bill mentioned, that you're looking straight on. So there's a lot of challenges with some of these instruments. And then I want to also talk about, and so we've been talking about specifically about static pressure, which is the balloon pressure inside the duct or inside the unit that you're measuring. But here it lists velocity pressure as something that I think it's saying could be done by a MagnaHelic, and not necessarily here, but this is what Bill was alluding to with the measurement that I was doing with the 605i. Wait, no.
That person was you, Bryan?
510, yeah. That person was me.
Good fake surprise reaction, Steve.
Yeah. Thank you, Steve. I appreciate that. Humility is important, and I'm learning that more and more every day as I have older and older teenagers. So Bill, talk through that, because this is a challenge if you are trying to measure something more complicated like velocity pressure with a typical off-the-shelf manometer. You run into some issues there.
Yeah. So the pedostatic tube, and that's really the full name for it. People abbreviate it a lot of time and call it a pedo tube, but if you remember that pedostatic name, it's measuring two things: the total pressure as well as the static pressure. The difference between total pressure minus static pressure is the velocity pressure. That velocity pressure can then be converted into a velocity reading if you know things, or can approximate like the density of the air mainly. A lot of meters will just have that programmed into it. Some of them will allow you to correct for density. But I'll tell you about a mistake I made a long time ago, that I thought I could average the static pressures and then get an average velocity pressure. But you can't do that because of the relationship between, there's a square in there. So that's going to, square root in there, that's going to throw you off. So, but today it's more, I think it's a lot easier. A lot of the meters have built-in averaging and the calculations built into them already. So the pedostatic tube, you put it into a duct And something else to keep in mind is that the meter only knows what's going on, where the sample's being taken from. And if you look at any static pressure or a pedostatic tube, you'll see very tiny holes. So it's only in that region around the tip of the probe that it knows what's going on. That's why you need to take multiple measurements, because the airflow, and I think everyone knows this, the airflow going across the duct is not very uniform.
Right.
And in fact, near equipment transitions in ductwork, devices that are in the duct can cause even things to happen like reverse flow, eddy currents, negative flow. And you'll see a lot of that leading people down false trails and wild goose chases. And I think Steve knows a lot about that in the development work for like the TruFlow grid, because that's actually a device you stick in the duct that causes some turbulence, has to deal with turbulence, yet extract these measurements like we're talking about.
Yeah, that's the biggest problem with flow in ducts is there's never this wonderful long straight duct that you want. I mean, at least in residential.
Except in pictures.
Yeah, it's in pictures. And that's, there's actually the story that you began with of apparently it was Bryan trying to measure airflow with a pedostatic tube. There's actually two problems that are related, two problems that are unrelated. One is your manometer good enough? That's what Bill talked about first. And the other one is what Bill just mentioned now, which is, have you taken enough points, and do you have enough straight duct to even get enough points? So both of those are going to cause big errors with pedo tubes.
And I think this comes down to just to make this practical, we're talking residential here. So let's focus residential. Your average residential service technician needs a good quality manometer to do static pressure measurements. There's a wide range of tools that will do a decent job. The Energy Conservatory makes a really good one. We're going to talk about this in a minute here. If that's what you're doing, if you're doing what we're showing here, where you're measuring static pressure on the system, and that's a great place to start. You just have to know what that means. It's not a measurement of flow. It's not a measurement of volume. It is a measurement of pressure and pressure only. So the only way it's going to mean anything is if you know how the system is set up and you're referencing some sort of fan chart from the equipment. So not a terrible measurement to take, but not super valuable all by itself. And this is how you do it. You have your low pressure side connects into the return duct, your supply pressure or your high pressure side connects into the supply duct if it's an air handler, or in between the coil and the blower, or in between the coil and the furnace if it's a furnace system, and you get a number, and that number is your total external static. So not a bad place to start, but the misconception is that it is a airflow measurement, and it is not an airflow measurement by itself. So in terms of measuring total system airflow, the problem that we'll become down to is it's very hard. In this slide, it talks about doing the heat rise calculation method, which I have essentially just given up on in real life in the field. It talks about, you can do, your pedo tube type measurements, but most of those aren't going to be practical for a technician. So really, for a technician in the field, you're really left with two things. One, you're going to do it this way. You're going to take static pressure and you're going to reference a chart, which only works if you've got the original blower, everything's pretty much clean and set up properly. Or if you really want to get a good system measurement, I guess I also want to just say, if you have like a return that's directly underneath the unit, like we have sometimes in Florida, or a single return, sometimes you could do that with a flow hood. But generally, something like the TruFlow grid is going to be your best bet. So I want you to talk through that quickly, Steve, about what that is, so that people can kind of understand how that works.
I'll just preface that with saying you either pay in time and effort and knowledge, or you pay for the instrument. One way you're going to pay to get a high quality measurement. If you don't pay attention, you don't RTFM.
Yeah.
You don't pay for a high quality meter, you're not going to get a high quality measure. Don't have an expectation that you will, because you won't. I'll just say that, leave that to Steve.
Actually, Steve, if you want to pull up, do you happen to have a picture of TruFlow or some of your tools on your computer that you can pull up? Because I made you a co-host if you want to share some of those.
let me
go ahead and find that. And I want to talk about this quickly, because one of the things that Bill and Steve were talking about as we have this kind of duct system up, they were talking about where you can take measurements in the duct. And this is true less so of static pressure, but especially when you're going to take a velocity measurement, or if you're going to, do something like a duct traverse using the students, and I did it with a hot wire anemometer. If you imagine these bends here, you're going to get a lot of turbulence around these bends. You're also going to get a lot of turbulence around the unit, especially around the top of the unit here. And so you really want to try to take measurements in the center of straight ducts where there's minimal turbulence. And we all know that in real life, sometimes that's really challenging. As an example, in Florida, a lot of times we'll have these kind of short supply plenums, and then we immediately go to flex. Where do you take a good measurement there? There's not a great place to take it because it's super turbulent coming out of the top. Turbulent means the air is spinning and bouncing and moving. And then anytime you get near a bend or anything like that, and you're not going to take these measurements within flex. A lot of people ask that. I mean, you'd have to punch holes all through the inner liner and you'd essentially ruin it in doing that. Yeah. So there's just a lot of challenges to taking these full system airflow measurements. Your point measurements, you do that with a flow hood, and that's got its own set of challenges and things to watch out for, which Bill could talk about for 3 hours. But that's, pretty straightforward. That's going to be the standard way of doing that for most of us. But for full equipment measurements, it gets a little more challenging. So I'm going to turn this over to you, Steve.
Okay. Share screen. There we go. Okay. So this is the TruFlow device. This is the new digital version, and only a tiny number of people ever used the legacy one. This one's making it easier. So what this is this grid goes into the filter slot or the filter grill. Here's a kind of end-on view of it. It's made to be just about as thick, a little thinner than a 1-inch filter. So it goes into the slot in place of the filter and measures the airflow. And within about 5 minutes, you can do 2 to 4 static pressures, and then swap the filter out and the TruFlow in and get an accurate system airflow regardless of the condition of the equipment. This works just as accurately with an old fossil piece of equipment or a brand new piece of equipment. It's equally accurate either way. And it will also give you some information about the static pressures, so you can actually check the manufacturer's span chart. Oh, great. Bill's got the physical device right there.
And he's peeking through it like a convict for some reason. It's making me nervous.
Just want to show everybody lightweight, the relative size of it, the modularity. It's fantastic.
Yeah, it Bluetooths to your phone along. This is the manometer that goes with it. You do need a manometer for it to work properly. The manometer and the TruFlow are both talking to the app on your phone at the same time to get the static pressure and the TruFlow, and the airflow at the same time.
And talk a little bit about so this is the DG8, and I know like some people watching this are going to be like, is this an ad? No, this isn't like sponsored or anything. It just happens to be that Steve and Bill are two of the best people to talk about this stuff, and we have this challenge of everybody saying airflow before charge. Everybody says you got to check your airflow, but nobody tells you how to actually do it. I mean, they tell you, but then they tell you ways that don't really work in the field, and that's a significant problem for the trade. So specific to the DG8 manometer, it has some features in it that make it really unlike anything else on the market. And just talk through some of that. Yeah.
So what this comes from is, our main product that we've made for decades now is the Minneapolis blower door. And to do a blower door test, if you're not familiar with that, the one thing that relates to manometers is to do a blower door test, you need a really, really good manometer, and they cost about upwards of $1,500. But we recognize that there's a need to make just as accurate a pressure measurement, but you don't need 2 channels and you don't need to calculate blower door flow and stuff like that. So we took the same technology and put it in a smaller, simpler, cheaper manometer that's just as accurate. So this is capable of doing things like room pressures. Do you have enough return flow out of the master bedroom so that when you close the door, you're not pressurizing it? It's capable of measuring tiny pressures as well as, all the way up to 10 inches of water. So that, and this is what you need to make the pressure correction. A lot of people will ask the question about the TruFlow grid. They're asking, when I put this device in the filter slot, well, isn't that going to restrict the flow some if it's more restrictive than a filter or less restrictive than a filter? And the answer is yes. And that's why we're doing a correction for the difference. So you make a measurement of the static pressure with the filter in, and then make the same pressure measurement with the true flow in, and we correct it back to what it was with the filter.
Yeah. Yeah, and in the older version of it, which we've used for quite some time, didn't have some of this like connected, the Bluetooth connection and all that, which made it a little more challenging from the math standpoint. But it works really, really well. I mean, we've measured it. We've done our own testing with it, measuring against a flow hood and against some of the other reliable methods, and it's very, very accurate. So the point that I want to make here isn't that. It basically is that it's very difficult to measure airflow. And if you really want to be serious about it, then that really is the tool for measuring total system airflow. I mean, there really just isn't another easy way that a technician is going to be able to do it, other than, using your charts and measuring static pressure. And if you're not comfortable with that, well, then start there for sure. You definitely want to start there, but recognize that that's only going to be valuable if everything's clean and if it's all set up properly. If you're looking at the wrong column, then you're not going to get the right number. If your pins or your setup within your infinity control or your communicating stat, whatever, aren't set up properly and you're looking at the wrong thing, you're easily going to get the wrong information.
And if you take a good hard look at those tables, they tend to jump up in values of static pressure by like hundreds of CFM for hundredths of an inch of water column change. And then going back to what Steve said, if your accuracy is several hundredths, you're dealing with this really fuzzy number. You're somewhere on this chart in this region here, but it's better than the estimate of airflow per ton, but it's not quite a measurement.
Yeah. And I just learned a little bit more today about measuring static pressure. We're doing some testing on the system here in the office, and it's actually a residential system. But so I measured the static pressure about 4 inches from the evaporator coil, and then I put another probe about 18 inches farther downstream, and discovered that going farther downstream, the pressure is about 20% higher.
It's called static pressure regain.
Yeah, and how much static pressure regain do you get downstream of an A coil, and how far do you have to be from the A coil
before it changes?
Yeah, exactly. Out. And I measured several pressures all throughout our system and found out that there's more cases of static pressure regain than there are of typical pressure going down as you move down the duct, and it's just because there's not really a place in an entire residential duct system where you have fully developed flow.
Yeah, which is also why, in terms of commissioning a piece of equipment, you need to hit it from a couple different angles. So in order for us to do a better job than we are doing, first we have to get better at measuring airflow, but then we have to understand what we are measuring. And you make compromises. I mean, that's part of it. But a good technician makes compromises knowing they're making compromises, and then kind of doubles down on their data in order to kind of help verify that they're where they should be. And that's where a tool like MeasureQuick, using a couple different Bluetooth connected devices, is really going to help bring that together and say, like, okay, maybe my airflow measurement isn't as good as it could be, but by using MeasureQuick and its estimated airflow and looking at all of my other measurements, and they're all in the range that I would expect, then at least we can feel pretty good about it. So I want to talk about that quickly, this concept that a lot of technicians have. And so we're going to move to the refrigerant side just because we have limited time. But it relates directly to airflow. They get this sense that, well, as long as my pressures are good, then my airflow is good, right? So what would you say to a technician who says, well, look, my pressures are good, my superheat and subcool, I learned how to do that. That's good. That means my airflow is good, doesn't it?
Is that for me?
Sure, either one of you. Just if you have thoughts.
I think so. I'm getting a little out of my depth, and frankly, I don't understand the refrigerant side as well as the air side. But if you have, depending on the state of charge and airflow, you can get errors that compensate for each other, and it looks okay, but it's not.
Yeah, for sure. And you see this a lot because people try to compensate for one problem by doing something different. Specifically, adjusting the charge. And so you'll see this where people will overcharge a system, and it will show up in subcooling. So there is something to this, but you'll sometimes have like these just competing problems, and people will compensate, especially, back in the day when we had more fixed orifice metering devices. If you had low suction pressure, they would just keep adding charge. Your superheat would start to dive, but this is the issue when you don't have those numbers. And in terms of another thing I'll say to that is, another part is that you don't necessarily have the precision. So you may have a system that's within 10% of where it should be, and that based on looking at your refrigerant side readings, but you don't know that you're completely dialed in, especially with things like a dehumidification, latent removal, that sort of thing. That's where it really becomes important. You may have a system that looks okay in the numbers. Specifically, techs love to see high suction pressure, because that means that we're not close to freezing. And your compression ratios tend to be lower. So they're like, okay, well, that's good, but you may have a significant problem with dehumidification.
And isn't it true that this all gets harder if you're doing a hot pull down and, indoors 95 degrees?
Yeah. Yeah, that's actually another really good point. Yeah. Because if you have a system, if you're doing a commissioning as an example, it's going to be much more difficult to estimate your airflow when you're not at your design conditions. So the space is still hot. And so, techs have a harder time kind of knowing what to expect. If you're really experienced, you can do pretty well, but that's where doing something like TruFlow Grid, throwing it in there and just saying, okay, what is my airflow? It's completely independent of my refrigerant side readings. Make those adjustments first and then get your charge set. That really is the ideal way of doing that.
Yeah.
Any thoughts, Bill?
No, I was just looking at the chat in YouTube to see if we were what was going on there.
Sometimes they just talk about whatever they want. And
it seems like it.
We respect that about them. They're just having a nice time. We're having a nice time. We're having a conversation. They're having a conversation.
I get distracted.
It's really good.
By the pyro is looking forward to upcoming propane-based refrigerants.
Yes. Corey says in the Zoom chat, and we are very, very blessed to have Corey Cruz, the great Corey Cruz of the famous TXV argument, that he'll know what I'm referring to. Yeah. It was of 2018, I think. So just to prove that sometimes even knockdown, drag out arguments can end up in getting employees for Kalos. So it works out. Nice. It makes me happy. Anyway, so just focusing on specifically performance, that's the goal of this. I get these conversations a lot, or get in these conversations a lot, where people will say some version of, hey, I did it this way all along and I never had a problem. So I charged by beer can cold and I never had a problem, or I never measured static pressure.
Yeah, never had a problem that I know of.
Exactly. And that's the point. So to say you never have a problem, does that mean you started it up and it didn't just implode on you? Yes, I'm sure it did not just, turn into a fireball right away. That's not what we're saying. What we're saying is that you may have missed out on either performance, capacity, efficiency, longevity, or serviceability, breakdown, issues with servicing. Those are all things that if you're not careful on the front, that system may be operating 2% less efficient than it could be. But over the life of that unit, you're not giving the customer the value that they paid for. And airflow is just undisputedly the area that we screw up the most.
Yeah, you upsold them to the 20 SEER unit and they ended up with 16, Yeah. And there's, I forgot what I was going to say.
Okay.
It'll come back to me.
One thing I wanted to reference quickly, because I've got a couple refrigeration guys, a couple of our grocery guys are here in the Zoom chat. One thing that we learned, even on the grocery store refrigeration side, is that sometimes doing a comparative airflow measurement is enough. So there's a big difference in a device that needs to get the number exactly right, and a device that you're using and just kind of comparing it to itself. So for example, they'll use vane anemometers, relatively inexpensive ones, and they'll go down a case lineup and they'll compare case to case because they should all be the same, right? So now it becomes a game more of one of these things is not like the other than it is about really caring so much about what that velocity measurement is. It doesn't matter as much. You're not trying to calculate.
Can I jump in real quick?
Yeah, go ahead, Chad.
In refrigeration, like supermarket cases, the airflow actually is a very big, important thing, because if you don't have your proper airflow, especially open cases, you will lose your air curtain and it's not going to be circulating through that case. So really just looking at the manual, it'll tell you exactly your CFM should be out of your vents. And that's what we go by.
What, not to correct you, but you have to be careful with the CFM measurement, because CFM requires that you do a traverse. Velocity is really what you're measuring. So when you're taking one of those,
the feet per minute. Yeah, my bad.
Okay, so that's what you meant to say, right? Yeah. So
Yeah.
you're talking about velocity, and that's actually a really nice point to make.
Sure is.
I think Steve and I talked about this before, is that when you start doing comparative measurements, you could even take something like a decent vane anemometer, go around a house and compare the velocities from different supply registers. If the design is so that they should be fairly consistent velocities, and that's an assumption you shouldn't make, but when you're doing a comparative analysis, you can start to kind of pick up trends and things that are different than others, and you can start to make some distinctions there. So I'm not saying that you always have to have the point of this is, I'm not saying you always have to have the world's most expensive tools, but when you're trying to hit something like an airflow number for a piece of equipment, that's very different than doing something like going down a case lineup and measuring your velocity and comparing it to a chart or comparing it to different cases. Both of those are valid.
You can even do sort of some rudimentary balancing with just a vane anemometer in a residential. Yeah. So in a residential situation, as long as all the supply grills are the same and you're using your vane anemometer in exactly the same place, you can find out, at least relative to each other, how much airflow there is. Now, you're not going to be able to say, I need 123 in this room and I've got 123. You can't get there with a vane anemometer, but at least you can find out, okay, these two bedrooms are the same. They have the same number of windows, the same number of exterior walls, and this one has twice as much flow. Okay. That's not going to work.
Yeah, exactly. And this is where, the tools that are in a technician's toolbox run the gamut, which is why in this, I wanted to specifically focus on equipment performance during commissioning, because that's one time you're not doing a comparative check here. You're trying to objectively hit some numbers that are going to produce the EER, SEER ratings, capacity ratings that you sold the customer. Now, because I'm assuming that most people out there, even if they're doing a like-for-like installation, they need to hit the numbers that system was designed for if that piece of equipment is going to perform the way that the customer is going to be happy with. And we're certainly not perfect either at this. But really taking a good stab at commissioning when you first start the equipment is a huge part of it. So starting with using the best tools you can get your hands on to make sure that you got your airflow right, and then move into your standard measurements. And those are going to be, subcooling, superheat, suction saturation, what we call evaporator temperature. That's the way I want us to think about that. Don't say suction pressure, because that pressure doesn't matter. It's the evaporator temperature. And then your condensing temperature. Compare those to your indoor wet bulb, dry bulb, and outdoor dry bulb. Take those all and put them into a bucket, and you're going to come out with a pretty good sense of how your equipment is performing. But if you start with your airflow not being right, and then you start trying to make tweaks and adjustments to get around that, you're gonna have heartache, and at the end, you're gonna have a lot of performance problems, and you're gonna end up making other issues. Like in the grocery space, the example would be they call them valve tweakers. People who go and adjust expansion valves rather than checking the obvious. And the obvious in many cases is an airflow problem, and it's the exact same thing. You start making other adjustments rather than getting that airflow where it's supposed to be.
Yeah.
Cool. So I wanted to move over to you again, Steve, to talk a little bit more about the solution that you've created. We're going to do a podcast about this a little bit further, but talking a little bit specifically about kind of the evolution of TruFlow and how you see this being applied differently than these sort of instruments have been applied in the past. Because it used to sort of be like, all right, test and balance organizations, building performance organizations, but now we really want to get better airflow instrumentation into the hands of techs.
Yeah, so the evolution of this product came about, of course, from the original TruFlow. And, the geeky people like Bryan and Bill have known about the TruFlow for many years and have, preached it as a good, the accurate way to really know how much airflow is going through the system. But as we set out to make the next generation of the product, I realized that there was really a second problem besides just making it easier to make the measurement. And that is that if you're not a super geek like Bill or Bryan, you don't really know, okay, so I've got 273 cubic feet or CFM per ton. Is that okay? And so what I realized is we need an app to interpret the results for technicians to help them understand what they're getting, because there's just, technicians have to know so much these days. Let's make it easier. Let's make it, like, the navigation on your phone as opposed to the map book, where it's going to give you the guidance you need, and not only say what is the airflow, but tell you, okay, is that in a good range? And then if it's too low, let's look at the static pressures and see if we can pinpoint what's making it low. Is it because you've got a filter that's way too small for that 4-ton system? Is it because your return is way too small? Is it because you've got, somebody went up in the attic and knelt on a supply duct, and so you got a big restriction in the supply? And we can help pinpoint that by measuring the pressures in the system and help identify where the problem is once we go through the analysis. And I have to give a shout out to Ed Jonawak, because we're good at measuring airflow here at the Energy Conservatory and pressure. But as far as coming up with all these this detailed information about how much static pressure drop across a filter is too much and what should be the maximum supply static pressure, I mean, that all came from Ed. That we didn't have that expertise, and so we went looking for it and found it in Ed. So thanks, Ed.
Yeah, I was going to say that it's not measurement for measurement's sake; it's measurement for a solution.
Yeah,
which is what everybody's we're talking to. That's what your job is. You got to provide solutions. You got to fix things.
Yeah. And in terms of peak performance, like that's what we're trying to achieve here. We're trying to give the customer peak performance out of this piece of equipment. And so sometimes when a system is 12 years old and it's a little dirty and it's whatever, like, okay, at that point, maybe you're not so worried about peak performance and measuring all of this most detailed stuff. Maybe at that point, it's about cleaning the blower wheel, and so that's still valuable. But especially when we're delivering a new piece of equipment to a customer, I really think we would do well to think more about airflow and really dig into it. And a lot of that comes down to just as simple as, like Steve was saying, independently looking at your return and your supply. Is one or the other the problem, rather than always saying, well, I hit a total external static target, or my total external static's a little high. What specifically is causing this problem? Do you have low airflow and your static's not high at all? Okay, well, then that means that your unit's not set up to produce the amount of airflow. And only a tool like TruFlow is really going to tell you that. One of the questions that was in the chat that I wanted to ask you, Steve, let's see here. Who was it who asked? GT350R asked, does TruFlow allow for different filter sizes? So talk about that specifically with the new model, how that works.
Yeah, so we've got 7 of the most common adapter sizes that you can get. So Bill, please pop that out. So the plate fits into the adapter. There's the plate that makes the measurement. That's Bluetooth. That the Bluetooth is in there, and I'll hold up the adapter. So that adapter, can you get in on the size? Okay, so that's a 20 by 20 adapter that it snaps into, and there's 7 sizes. You can pick and choose your adapters, or you can just say, I want all of them. And in addition to the 7 common sizes, there's another one which is kind of like the maximum size, and you can cut it down to fit whatever oddball size. You get those weird carrier half sizes, and so the cut to fit adapter is intended so the technician on site can cut it down, apply the gaskets, and then use that. And then from then on, you have an 18.5 by 23 or whatever the weird size is.
Yeah, so definitely. And in terms of like investment, I want to make it clear, like this is an investment that you're going to have to set up. Yeah. And so what I would suggest doing, if you're looking at this like, I don't know how I'm going to outfit my entire organization, pick some of your best installers who are going to be doing a lot of higher end equipment. That's where you start. And then, then get it to where all of your install crews have it, and then get to where your senior techs have it in addition, and then move on. I mean, that's the journey that I'm on right now. So, yeah. I don't think anybody is expecting that it's, you're going to go and buy 30 sets of these, although I don't think Steve or Bill would mind too much if you did.
We'll be okay. Yeah.
Yeah, right. Okay.
But let me point out, there's one you didn't mention, and that is something that's really come out since we started sending prototypes out to people to test this. There's another application we really hadn't even thought about, and that's putting it in the hands of salespeople. Because if you can get a filter size and send one out with the salesperson, really this is literally a 5-minute test. And after that, they do that test, they can easily figure out, okay, the static pressure is way high off the charts, but if we replace the 3-ton with a 2-ton, which is correctly sized, not oversized, are we going to be okay with the duct system as it is, or is it still too restrictive? And if you know the static pressure in the supply, static pressure in the return, and the airflow, you can figure that out relatively easily.
Yeah, that's a really good point. I mean, getting salespeople to use tools that might require a little extra work, but
Right.
but no, it actually is a really good point in terms of like preventing problems. This is where I think a lot of salespeople would be like, well, hey, how does that help me sell a unit? Might not help you sell a unit, but it's going to help you from having to go back 400 times to try to fix a faulty duct system or an improperly sized system.
What we're hearing from people, from customers that have tested this out, I'll give Joel Becker a shout out. He said he wants to put one in the hands of all the salespeople because he thinks it will help him sell more units, because it will distinguish him from the other companies that had no idea if when they put that new system in, it's going to work just as bad as the old one, or whether they actually can solve problems.
Yeah.
And so, you heard Alex Meany talk about load calc theater. This wouldn't be theater, but airflow measurements as a selling tool. Yeah.
And it's not just the measurements. It's sort of like any kind of measurement, you need to have an interpretation of the measurement.
Yep.
So the digital true flow is like reading someone's palm, and then the DG8 is like reading the bumps in their head. So you get a really better idea. It's still sort of an idea of what's trying to go on there. But
that was a really interesting analogy there.
It was. I don't know where it came from.
That was wow. That was intense.
I'm staring at my bald head here in the screen. So I guess it's.
I'm a little concerned that Bill's saying this is like palm reading and snake oil, but I think hopefully the product will speak for itself.
Yeah, I think so. All right. So as we wrap up here, I would be remiss if I didn't tell folks how they could find this kit, this product. So I'll let Bill mention how they can go about doing that.
So TruTech Tools, of course, has the product. We have some in stock already. You can also buy it directly from the Energy Conservatory off their web store. And I say that because we're really interested in people, technicians, getting good tools in their hands and using them well to the benefit of their customers and their companies. So you don't have to buy from me, you don't have to buy from Steve, but you got to buy it from either one of us. Or there's a couple of the places you can buy
it from both of them.
Yeah.
That would be just fine.
Yeah.
Absolutely. So so this TruFlow, any special like model number that they need to look for? The DG, the manometer, but
there's a little bit of choices to be made with the TruFlow, and that is, do you want all the adapters, or do you want to pick and choose, depending on how many filters you typically deal with, filter sizes? And then the other one you have to decide is, do you already have a DG8 or a DG1000, or do you need the manometer? So there's two choices to be made, and that'll kind of lead you in the right direction. But if you just look for TruFlow on our website or TruTech's website, you'll find the same information, the same kits are available depending on whether you need a manometer or not.
Yeah, for sure. In terms of hierarchy here, I want to go ahead and nail down, if you don't have a manometer, go ahead and get a manometer. Get just a decent basic, field piece, testo, whatever manometer, and start measuring static pressure. Start doing that. If you're not measuring subcool and superheat on every job, especially every commissioning job, well, go ahead and get those tools. Now, of course, people are going to be like, but you say I don't have to do non-invasive testing is the way to go. Okay, that's sort of a step up. I'm just saying, to get started, you need to know how to do those things. You need to know the significance of static pressure. You need to know how to, kind of distinguish, all right, which number's higher, return or supply, do things like measuring pressure drop across a filter with your manometer, measuring pressure drop across your coil with a manometer. Those are things to start with. If you don't know how to do that, I have like a zillion tech tips and videos on all this stuff. Just you can use the app or go to hvacrschool.com and go and search and find out more information on that. Also, TruTech Tools has a lot of really great resources on all the same sort of things. But for your residential service technician, I wouldn't get too, generally, you're not going to benefit by doing a lot of traverses. You're not going to benefit by using something like a pedo. You're going to want to know how to, basically use an airflow hood would be a next step. And then something like TrueFlow is really your best bet for total system airflow. Once you understand airflow, then you're going to be able to set up systems much more accurately on the charging side and on, making those fine adjustments. Even things like, heaven forbid you ever did have to adjust an expansion valve. You only want to do that once you know everything's clean, everything is, and the airflow is what it's supposed to be. So many times, and Chad keeps making the joke, made some adjustments. That's what they always say in grocery. Everything is you made some adjustments, but there's no numbers to it. Taking better measurements and understanding those measurements and having confidence in the instruments that you're using to take those measurements are really critical to make sure we're doing what we're supposed to do.
Could you give me screen control here? I just want to show, because there was a question in the chat.
Let's see here. Screen control. I'm going to make, I made you co-host, so you should have it. Yeah.
All right.
Should be good.
There we go.
All right.
So someone had said we don't have any in stock. The full kit, they're ramping up production. So we do have many of the kits and many of the adapters in stock. And we actually show the stock number now for anything that we have. So.
And I'll just make one little piece of information. So if any of the viewers have been following kind of the delivery legacy, we've shipped out quite a few of the TrueFlows, but now we've had a delay. One of our suppliers was not able to get us the materials that we needed. And, breaking news, we just found out today that we'll be getting the last components that we need to start shipping in higher volumes. They'll start coming in next week. So we'll be able to replenish stock at TruTech and also here at TEC. So within the next few weeks, we should be able to ship, meet the volume. Right now we've got, we're back ordered, but that's going to get cleared out in the next few weeks.
Yeah, we have a lot of confidence in the product. We put in a big stocking order. So
yeah.
Yep. It is great. We saw it demonstrated at the symposium. I got a chance to play with it. Really, really amazing product. And the manometer is also an incredible manometer, really good quality manometer. So well done. Well done on that front. One thing I'm going to leave you with is techs out there, students, before you're going to buy something to do anything more advanced than like a basic manometer, you're going to want to get some good advice. So you can look at, obviously we've talked a lot here, but TruTech Tools is a great source of just advice for what's going to be the best instrument for a particular application. So avail yourself of that. They have a really nice chat there. You can try to reach out to me, but good luck. I'm a little tough to get nowadays. But yeah, definitely take advantage of the support from TruTech, because that's what they're known for. So
appreciate it.
Yeah.
All right. Thank you so much, Bill and Steve. We're a little bit over. Students, thank you so much. And everybody who watched the live chat, it means a lot that you show up. We had over 100 folks almost the whole time. So that's pretty cool.
And I'm going to make a quick plug for my podcast.
Yes, please do.
Okay. Building HVAC Science podcast. Bryan got me into podcasting, so it's his fault. Anything you don't like about it, his fault. If you like it, it's my credit.
Absolutely. I agree with that wholeheartedly.
I do a lot of different takes, and he does different subjects, different people, different approach, but it's fun, and I encourage you to give a listen.
Yeah, it is great. Very in-depth on the both the building science side of things as well as the HVAC side. Yep. Lots of instrumentation stuff on there as well. So
yeah.
Thank you.
So we just last week I'll give a little plug for our YouTube channel. If you want more information about the TrueFlow, look at our intro webinar, which was just went out last week. Look at Energy Conservatory, our YouTube channel, and you'll find the webinar out there, and that'll give you a lot more information and you find out exactly what it's all about.
Sounds good. Damien said that I need to say hi to my best students. I don't know who that is, Damien, because it certainly ain't you. That's not nice. That's not nice. Everybody knows I love all of my students, even Damien. All right. Thank you guys so much. Have a wonderful evening, and I appreciate you showing up on such short notice. It's really awesome.
Thanks for the invitation.
So. All right.
You do good work. Mark, you do good work. Yep. Thanks.
Great discussion. Thanks.
All right.
Bye.